Ever wonder how massive, complex software systems actually get built in the real world? Well, welcome to our explainer on section 23.2. Today, we're diving deep into the core concepts and really the absolute importance of plan-driven development in software engineering. If you're studying up for your exams, you are in exactly the right place. Let's get started. Here's a quick look at our agenda for this session. 1. Intro to plan-driven development. 2. When to use plan-driven. 3. The project plan structure. 4. Supplementary project plans. 5. The planning process workflow. And finally, number 6, summary and exam prep. Grab your notebooks because we're going to cover a lot of ground. Section 1. Intro to plan-driven development. Okay, so what exactly is plan-driven development? Simply put, it's often considered the traditional engineering approach to managing large software projects. If you're totally new to software engineering, here's the easiest way to wrap your head around it. The entire development process is planned out in granular detail before a single line of code is ever written. We are sitting down and figuring out exactly who is going to do what and exactly when they are going to do it, right from day one. Managers absolutely rely on these comprehensive upfront project plans. Why? Because they use them as a strict baseline to measure actual progress once the real work kicks off. Now, you really can't talk about plan-driven development without bringing up Agile development, which, as you know, we covered earlier in the course. Agile is an approach where planning is incremental. It's continuous. It intentionally delays decisions to avoid unnecessary rework, mostly because, well, requirements change, right? Plan-driven is the complete opposite. It requires detailed early commitments. It demands that we map out the system requirements completely upfront so we can design a rock-solid software architecture right out of the gate. So while Agile is super fluid and adaptable, plan-driven requires these detailed upfront blueprints before any coding happens. Section 2. When to use plan-driven. Finding the right fit for your project. Please, and this is absolutely crucial for your exams, remember that it isn't just a simple case of Agile is good, plan-driven is bad. The choice depends entirely on the project itself. Plan-driven development is absolutely essential for large, safety-critical systems. Imagine you're building the control software for a commercial airplane. That software requires extensive upfront analysis and rigorous certification before it can ever see the light of day. You can't just figure that out incrementally on the fly. It's also vital for massive multi-company projects. When you've got different contractors working concurrently on separate subsystems all across the globe, you need tight, flawless coordination. You have to define the interfaces between those systems completely before development begins. So, long story short, use this method when safety certification and global coordination are simply non-negotiable. Section 3. The project plan structure. Let's look at the 7 standard sections. In a plan-driven project, the project plan is basically your Bible. It's the central document. It usually consists of 7 standard sections, so let's walk through the first 4 right now. First up, the introduction. This just briefly describes the project's objectives and its constraints, things like budget and time. Second is project organization. This maps out how the development team is structured and the specific roles everyone will play. Third is risk analysis. This is where we sit down and describe what could possibly go wrong, the likelihood of it actually happening, and our proposed strategies to minimize those risks. Fourth, we have hardware and software resource requirements. This specifies the exact tools, the support software, and the hardware needed, and it even includes price estimates and delivery schedules if we need to purchase things. And this perfectly leads us to the final 3 sections, which map out exactly how the daily work is executed and tracked. Section 5 is the work breakdown. This is where you slice the overall project down into specific activities and identify the inputs and outputs for every single one. Section 6 is the project schedule. This looks at the dependencies between those activities, estimates the time required to hit our milestones, and assigns specific people to the tasks. Finally, Section 7 covers monitoring and reporting mechanisms. This defines exactly what management reports need to be produced, when they are due, and how the manager will track actual progress against the plan. So, to recap this whole document, a core plan establishes the goals, roles, risks, and resources, and then maps out exactly how the schedule will be executed and monitored day to day. Section 4. Supplementary project plans. Because sometimes the core plan just isn't enough. Let's look at these 5 common supplementary plans. Think of these as incredibly detailed appendices for specific, critical areas of the project. First is the configuration management plan, which sets the procedures for managing different versions of the software and tracking all the changes. Next is the deployment plan. This details exactly how the software and hardware will be installed in the customer's actual environment, including how to migrate their old data over. Then we have the maintenance plan, which predicts the future support requirements and the costs once the software is actually live. Fourth is the quality plan, which lays out the specific quality procedures and standards the project absolutely must follow. And finally, the validation plan, which describes the resources and the schedule for testing the system to ensure it actually does what it's supposed to do. Remember, for complex engineering programs, that core plan we just talked about is really just the starting line. These supplementary plans are vital to getting the job done right. Section 5. The planning process workflow. Let's see how this works in the real world. All right, before we dive into the workflow itself, we need to clear up a very common student misconception. We have to explicitly define two terms, milestone and deliverable. They are not the same thing. A milestone is purely an internal progress check. It's a predictable outcome or logical end to a stage of the project where progress can be reviewed, usually documented by just a simple report. A deliverable, on the other hand, is a specific work product that is physically handed over to the software customer. This could be a requirements document or the initial system implementation. Deliverables are almost always explicitly specified in the contract. Make sure you memorize that distinction. Now, what's really fascinating here is how we can visually trace this continuous loop of planning. The project planning process isn't just a set it and forget it one-time event. It is a highly iterative process. Let's break down the actual steps of this loop. The process always kicks off by identifying constraints, like your hard budget or delivery date, alongside identifying your project risks. With those clearly in mind, you define your milestones and your deliverables. Once those are set, the project planner defines the estimated schedule. And then, the team actually gets to work. They do the work. After a few weeks, management will monitor progress against that initial plan. And because early estimates are basically guaranteed to be approximate, this turns into a continuous looping process that literally doesn't end until the project is completely finished. But let's be real, how does this play out when things don't go perfectly? Which in software engineering is almost always. When monitoring progress, managers encounter different decision branches. If everything is fine, great, keep going. If there are minor problems or slippages, which is completely normal, the manager simply updates and modifies the project schedule. However, if there are serious problems, it triggers a much heavier, more serious process. The manager must initiate formal risk mitigation actions and a total project replan. If those mitigation actions fail, a formal technical review has to be called to find an alternative approach. And in the absolute worst-case scenario, this review might even result in the project being canceled entirely. So to recap the workflow, identify constraints, schedule, execute, and always be prepared to replan iteratively when problems pop up. Section 6. Summary and exam prep. We have covered a lot of ground today, so let's rigorously recap the most important concepts you need to lock in for your exams. First, understand exactly when to use plan-driven development. It is for large, safety-critical systems or multi-company projects requiring high coordination. It is not just used because an organization is old-fashioned. Second, know all 7 standard sections of a main project plan, from the introduction right through to those monitoring mechanisms. And finally, you absolutely must be able to write down the strict definitions of milestones as internal checkpoints versus deliverables as external products given to the customer. So if you take away just one crucial point from this whole explainer, let it be this. The textbook explicitly notes that if a project is technically advanced, initial estimates will almost certainly be optimistic. No matter how hard you try to consider all the eventualities, things will go wrong in software engineering. Because of that, managers must continually update their schedules, plan pessimistically, and always build contingency into their plans to minimize disaster. So we know we have to plan, and we know we have to update schedules when those initial optimistic estimates inevitably fail. But how do we actually calculate and visually track all these incredibly complex timelines, dependencies, and resources on a daily basis? Well, that is exactly what we're going to uncover in our next explainer on Section 23.3, Project Scheduling. I will see you there.